the distributive property part 1, lesson 9. We're going to use the distributive property to help us with calculating. Today's ICANs. I can use a diagram of a rectangle split into two smaller rectangles to write different expressions representing its area. I can use a distributive property to help do computations in my head. So help you with solving things more quickly. So make sure that you've got today's date, your ICANs, and you're ready to move on. All right, let's look at some ways to multiply. So find each of these in your head. You know, this one's not bad. If you think about it, 100 times 5 is 500, and then 5 times 2 is 10, so that gives you 510. Again, we can think of the same thing here, can't we? 5 times 100 will give us 500, and this is 2 less than that, so that would be 2 groups of 5 less. So that would make 490. What about here? Yeah, if we think of this as 5 times 1,000, that gives us 5,000. This is 1 less, so we need 1 group of 5 less. So instead of 5,000, we have 4,995. Great thing with doing this is it can help you solve, basic multiplication stuff much more quickly and efficiently than to always go, well, let's see, 102 times 5, multiplying each of the parts and carrying them through. There's nothing wrong with doing that, but if you can, especially if you're pretty fluent with your multiplication up to your like times 10 groups, then this can really go pretty fast. All right, let's talk about representing area of a rectangle. So taking a look at this first one here, which expressions would represent the area of the whole outer rectangle? Okay, so we have 6, and we have a measurement of 3 and a measurement of 2. So what are ones that are going to make this work out? Well, we know that it's going to be length times width, right? To find the area. Well, this one doesn't show length times width, does it? Because it's just adding every single thing. What about this one here? 6 times 3 plus 6 times 2. Yeah, because that would give you the area for the one and the area for the other one, so that would work. What about here? 6 times 3 plus 2. No, because all this was going to do is give you the area of this piece and then just add one side of the other one's. I don't think so. That doesn't work. All right, so we still have 6 here. We have 6 times 5. If I add those two together, that does make 5, so that would work. What about here? 6 times the sum of 3 and 2. Yeah, that works because really what we're going to do is we're going to take that 6 times both those parts, and so we'd either add it like it did here, which is more of a distributive property, meaning that we multiplied the 6 by each of those pieces, or we could add them together beforehand and then multiply by 6. What about this final one? Yeah, that doesn't work. This would be more of volume. If the height was 2, then that would work, but it's not, so that one doesn't work either. Okay, let's look at another example. What about here? We're going to try and find the area of the shaded rectangle. Okay, so this one's saying 4 times the 7 plus 4 times 2. That 4 times 2 does give you the area here, but 4 times 7 gives you the entire area. That doesn't give you the blue area. So we wouldn't want to add those together, so that doesn't work. What about here? 4 times 7 times 2. Yeah, that doesn't work. That's that common problem that we run into, is that we just see a bunch of numbers and we just start multiplying because that's what we do for area. That's not always the case. What about here? 4 times 5. That does work, right? Because if this entire distance is 7, if I take off 2, that leaves me with 5 here for this other piece. So then it is 4 times 5. What about 4 times 7 and then subtract out 4 minus 2? Well, order of operations tells us we're going to multiply or divide before we add or subtract. So we would have 4 times the 7, and then the area of this square, or this rectangle, 4 times 2, and we subtract it out of the total. Yes, that totally works. What about here? Yeah, this works again because this is the same as this, except that now we've distributed the 4 multiplied by each of the parts before we subtracted. So here is just saying subtract and then multiply the pieces together. What about here? Yeah, you can't add and subtract and get the same answer for there, so that doesn't work. What about this one? Yeah, this isn't like addition. You can't just switch things around. This one's saying that if you take 4 times 2, you can subtract out the 4 times the 7 and get this space here. That's not going to give you the number that's there. That's going to give you something different. You have to take the entire total and subtract out the piece that you want to take off. That's why this one works, but this one does not. Let's get some further practice in here. Okay. So, if your business, whatever your business is, sells 15 items and you sell them for, it costs you $17 each, but then you can sell them for $20, how are you going to find your profit? Yeah, so what you're going to have to do is, you know that 17 is the cost. You want to find out how much you've got for your total that you make. So that'll take the 15 times the 20. That's how much money you're going to get from selling them. But then you have to subtract the cost. And what's that going to be? Yeah, the 15 times 17, right? That's one way to think of it. What's another way? Yeah, you could just do 15 times, oops, whatever the cost is of the, or whatever you get after you take the $20 that you sold it for, the $17 that it cost. So then you're talking about, what, $3? So then our final is $45 total made. And you could have done that here. You could have taken the 15 times the 20 and you would have gotten 300. And then here you would have taken the 15 times 17, which would have given you 255. Subtract out, and you still would have gotten 45. But you still are processing it the same way. And, you know, when you're looking at these, it's about what is going to set it up the best for you to solve. All right, we're not going to fill in this entire table, but we are going to look at a few of these and kind of think about some different ways. Like, so here what they're saying is you could do 5 times 98, which would be the same as 5 times 100 minus 2, which would be the same as 5 times 100 and 5 times 2, which is also the same as 500 minus 10, right? Because the 5 times the 2 and then the 5 times the 100, you still get 90, 490, excuse me. What would be a rewrite for this? We have 33 times 12. We have parentheses 33 times 10 and 33 times 2. Yeah, it should be 33 times 10 plus 33 times 2. What's that look like here? Yeah, it'd be 330 plus 66. Should have gotten 396. Let's skip down a few here. What about here? 100 times, then we have 4 hundredths plus 6 hundredths. Okay, so you can think of this as the 100 times 1/10, right? Because 4 hundredths and 6 hundredths together would make 1/10 or 10 tenths. You could think of it as, let's see here, 100 times that 4/10, or 400s, excuse me. Let me fix this. And then you'd still have to add the 100 times 6,000 or 600s. Here you're talking about what? Yeah, 4 plus 6, which is 10. Which makes sense back with the original, right? Let's go one more complicated. What about this one? 8 times 1/2 plus 8 times 1/4. Yeah, so you're talking about here 8 times 1/2 plus 1/4, right? You've just distributed that 8. What about back here? Still got your 8. What's 1/2 plus 1/4? Yep, 3/4. What about here? Well, 8 times 1/2 is 4. 8 times 1/4 is 2, 6. You know, when you're thinking about these, you can think of them like what we did back in the previous part. Let me jump back there real fast. And draw some kind of picture to figure out the area. Those are certainly ways that you could do it. You know, and with each one of those ones that we wrote out, we thought about how those could be still using that multiplication piece in there and how you could change that multiplication to go through and solve. You know, we had this being the same as this one right above it, 6 times 5, because you're really thinking about that's just really taking that 5 and splitting it into 3 plus 2. So you can distribute or change, break those numbers apart in whatever way you need to help you solve the most efficiently. So the big thing with this is that you can use that distributive property to break things apart to help you solve more quickly. You don't always have to have a calculator there. You can do sometimes a lot faster without a calculator if you're just thinking carefully about what you got and just look at the parts. But we are all set. Thanks for watching, or something like that.